P1 Summary. Scientific explanations. Scientists think up explanations for data from experiments. The explanations are tested by comparing their predictions with data from new experiments. Scientists use journals and conferences to inform about their experiments and explanations. A scientist's judgment about an explanation may be affected by their personal background. An explanation is only accepted when it can account for all the data from experiments. Scientists repeat experiments done by others to check their data. The solar system. The solar system was formed from gas and dust in space about 5,000 million years ago. The distance of a star can be estimated from its brightness and parallax. The star at the centre of the solar system is called the Sun. Earth is one of the 8 planets which orbit around the Sun. Moons orbit some of the planets. Comets, asteroids and dwarf planets orbit the Sun. The source of the Sun's energy is fusion of hydrogen nuclei, making it hot enough to emit light, which moves through space at 300,000 kilometers every second. Galaxies. The Sun is one of thousands of millions of stars in the Milky Way galaxy. The universe is made up of thousands of millions of galaxies. Redshift and distance data suggest the universe expanded from a single point about 14,000 million years ago. The expansion of space means that the greater the distance to a galaxy, the faster it appears to be moving away. The redshift of light from galaxies can be used to measure how fast they appear to be moving away. The changing Earth. The oldest rocks on Earth are about 4,000 million years old. Mountain building, earthquakes, seafloor spreading and volcanoes happen at the edges of tectonic plates. The theory of tectonic plates explains Wegener's idea of continental drift. The Earth's solid crust floats on a soft mantle and is continually worn down by erosion. Convection currents in the mantle split the crust into tectonic plates and moves them. Seismic waves. Earthquakes produce waves which carry energy as they travel through the Earth. P waves are longitudinal, which can move through the liquid core. S waves are transverse waves which can only move through the solid mantle and crust. Waves have an amplitude, a wavelength, frequency and speed. Equation. Distance moved by a wave equals wave speed times time of travel. Equation. Wave speed equals frequency times wavelength. P2 Summary. Cause and effect. If changes to a factor always result in changes to an outcome, then they are correlated. Scientists will only accept that a factor causes an outcome if they can explain it with theories. Scientists establish correlation by comparing the outcome of large samples whose only difference is the factor. Risk. People's perceptions about risk may be unrealistic. They fear the unfamiliar, but will minimize risks from things they enjoy doing. We have to make decisions about risk all the time. Some risks are greater than others. Risk can be quantified by measuring the chance of it happening in a large sample over a period of time. Both the chance of risk happening and its consequences are considered when making decisions about risk. Electromagnetic radiation. The intensity of radiation is the energy it delivers per second per square meter of an absorber. Water in our cells transfers energy from microwave photons to heat. The heating effect depends on both the intensity of the radiation and the length of exposure. Risk of harm from microwave radiation can be reduced by surrounding sources with metal reflectors. Low intensity microwaves from mobile phones may be a health risk. Ultraviolet, X-ray and gamma photons have enough energy to ionize atoms which absorb them. Cells exposed to ionizing radiation can die or become cancerous. Dense materials absorb X-rays and gamma rays. Sunscreens, clothing and the ozone layer absorb ultraviolet radiation. Electromagnetic radiation carries photons of energy at 300,000 kilometers per second through empty space. The 7 types of electromagnetic radiation in order of increasing photon energy are radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. The energy of a photon increases with increasing frequency or decreasing wavelength. Global warming. The Sun transfers energy through the Earth's atmosphere as short wavelength radiation, that is, light. Light absorbed by the Earth's surface, heating it up. Burning fossil fuels has increased carbon dioxide in the atmosphere, causing climate change. The warmed Earth emits long wavelength radiation, infrared, some of which is absorbed by greenhouse gases, carbon dioxide, water vapour and methane in the atmosphere, heating it up. Communication. Radio waves and microwaves carry TV and radio broadcasts because they pass through the atmosphere. Sound and images can be transmitted as digital signals by switching waves on and off. The quality of received sound or image increases with the number of bytes of information transmitted. Light and infrared carry information long distances along optical fibers. Although signals become weaker and noisier as they travel, the pattern of ones and zeros can often be restored at the receiver. A signal is an electromagnetic wave which has been changed by some information. An analog signal is the result of continuous change. A digital signal is the result of switching the wave between two values called 1 and 0. P3 summary. Making decisions. People may disagree about which technologies should be allowed. Some decisions may be based on the best outcome for the greatest number of people, or a moral sense of right and wrong. The benefits of science-based technologies must be weighed against their costs. Human activity may have unintended impact on the environment. Scientists may be able to suggest ways of reducing this impact. The development of science-based technology is often subject to government regulation. Electricity. Many power stations use a primary energy source to boil water into high-pressure steam. The steam passes through turbines, forcing them to spin round. The turbines spin the magnets inside generators so that the voltage appears across a coil inside. Increasing the rate of energy transfer from the primary source increases the current in the generator. The efficiency of a power station is the ratio of its useful output to the total energy input. Electricity can transfer energy easily from one place to another along the national grid. Domestic electricity consumption is measured in units of kilowatt hours, or abbreviated kWh. Electricity is a secondary energy source made from primary energy sources such as fossil fuels, uranium, wind, water and sunshine. Electric current transfers energy from a power supply to an electrical appliance. Energy transferred equals power times time. The power of an appliance is the energy transfer per second. Power equals voltage times current. Nuclear power. Nuclear power stations produce radioactive waste which emits harmful ionizing radiation. Nuclear power stations are expensive to build, but their fuels do not emit carbon dioxide. Exposure of people to ionizing radiation can result in cancer. Exposure by contamination is often more dangerous because the radioactive material has been incorporated into the body, so it cannot be removed. Exposure by irradiation can be limited by shielding and keeping away from the source of radiation. Renewables. Solar cells produce electricity directly from sunlight without producing carbon dioxide. Solar power requires a lot of land and, like wind power, is very weather dependent. Hydroelectricity has a large environmental impact as well as being expensive to build. Geothermal power can only happen in places where rocks are hot near the Earth's surface. Wind turbines are spun directly by the wind. They do not produce carbon dioxide, but have a visual impact. Carbon fuels. Biofuels, e.g. wood and plant oils, are renewable and result in no net change of carbon dioxide in the atmosphere. Some fossil fuels will last longer than others, but they will run out eventually. Fossil fuel power stations can easily make large amounts of electricity, but they are expensive to build. Coal, oil and gas produce carbon dioxide when they are burnt to make electricity.